Can you all confirm if you can hear me clearly? Is everyone hearing me clearly? Okay, thank you so much for that. I also need somebody to talk, uh, just to be sure if my internet is working perfectly. Can somebody confirm? Can you all hear me clearly?
Yeah, we can hear you clearly.
Okay,
Yes.
okay, thank you so much. Thank you so much. Good day to everyone. I want to welcome you to my lecture today. So I got a little emergency, but it's clearing out. Of course, I'm actually going to return to in-person teaching on Wednesday. Of course, today, just like what I said last week, uh, I'm actually gonna walk us through some revision, like and also provide some information about the midterm one. So, like I said, we got today and Wednesday for that. Okay, so our four of us starts with this. Give me 1 second. I'm actually gonna share my whiteboard right now. I'm gonna share my whiteboard right now. Give me 1 second. I need you to confirm if you can actually, if you can see my whiteboard. Can everyone see my whiteboard?
Yeah,
Okay, thank you for confirming that. Okay, so today I'm actually going to say we got 6 problems in the exam. We all know exam one is going to be conducted on October 17, Thursday this week. And of course, you know, we're gonna have 6 questions in all. Okay, we're gonna have 6 questions in all, and I want to start right now. I need you to pay attention, and this is being recorded, and I'm actually gonna share my recording, and from time to time, I also want you to go to, to check for updates on the canvas. But right now, I first want to start by giving you the idea of how many questions we're going to have in the exam one. Now I'm going to say for problem one, okay, for problem one, okay, the problem one is actually multiple choice, okay, and we're going to have 14 questions, okay. Uh, Out of the questions, number one is actually going to be extra credit, whatever you choose, whatever option you choose, is going to be correct. So that's what extra credit of 1 point and 13 other questions, each of them was shall 3 point. So in all, okay, problem one, 40 points. Okay, I'm going to say that again. There are 14 multiple choice in problem one. Okay, question number one of the multiple choice is actually going to be for extra credit, whatever option you choose. Okay, you're actually going to have 1 point. Then we got 13 other questions in problem one. Each of them was 3 point. Of course, if you multiply 3 by 13, that will be 39. And of course, 39 plus 1, that's going to be 40. Okay, so problem one, we got 40 points. And this particular problem, for the 14 questions, will revolve around what you've done all the way to Friday. Okay, so uh, if that is clear, or is there anyone who need clarification on problem one? Is there anyone who need clarification on problem one? and what's going to be on problem one. I can see, okay, I thought somebody want to talk. Okay, so like I said, you can actually chat with me. You can talk. In fact, I would appreciate when you talk, in case you need clarification. If you understand what I said about problem one, I need you to say yes, or you comment yes, or you give me a thumbs up.
Yeah.
Okay, thank you so much. Oh, thank you for confirming that. Okay, so I actually want to go to problem two now. Okay, so problem two, we actually test your knowledge, okay, on comparative box plots, on box plots. Okay, you got box plots, and you have a good number of them in a particular graph. Maybe they're going to ask you a question on comparison, or they're going to, so you need to get yourself familiar with box plots. You need to be able to understand the five number summary. How can you identify that from the box plots? Okay, you know how to get a minimum, you know how to get a maximum, you know how to get a first quartile, you know how to get a second quartile, you know how to get a third quartile, and you also be able to know how to compare average, like comparing the medians. Okay, so and you also need to understand how do we compute range. Of course, we all know range is the maximum minus the minimum. Okay, you also going to talk about how to compute IQR. Now, somebody said we need to know how to do it in R. No. When I get to the question that involve R, I will let you know. Okay? Somebody just text or chat with me right now. All of this is not about R. Not at all on R. So you're gonna compute them by hand. Okay? So when I get to R, I will let you know. Now, the question on that is actually gonna worth 10 points. Okay? That's gonna worth 10 points. Now, I want to go to problem three now. Now, to problem three now, okay, um, it's actually gonna ask, it's gonna be a question on probability. Okay. Now, probability involving uh contingency table. Okay. You've been given this, you've done this before in the assignment. So I will advise that you revisit your submission. Like I said, all assignment solution, okay, will be published tomorrow. All assignment solutions. Okay. And this particular point is actually going to worth 15 points. I mean, this particular question will worth 15 points. Okay. So watch out on probability. You're going to compute all of that with your hand, manually. There's nothing like R. So problem one, two, three, nothing like R. No R. One, two, problem one, problem two, problem three. Now, I want to go to problem four now. Now, in problem four right now, the problem four will test your knowledge of the use of Z-score. The use of Z-score. Okay? You know, probably you're going to be giving maybe a test, maybe two students wrote a test, and you know the average, you know the standard deviation, and you want to compare. Okay, which student perform better? Of course, if you want to do that, you need to compute your Z-score. Okay? And when you're computing your Z-score, you know what we normally use, Z, okay, X minus mu over standard deviation. And don't forget, the higher the value of a standard deviation, the better is the student performance. Okay? So that's going to test your knowledge on Z-score. Okay? And you actually that is going to go for 12 points. So there's going to be questions on that are going to be on that will totally worth 12 points.
Will we, I have a question. Will we be given the standard deviation and the mean to compute the z-score?
Yep, you're gonna be giving. Like I
Okay.
said, they're gonna give you like you have two students now, and they're gonna say, okay, this student and this student wrote the exam. This is the average. This is the standard deviation. They're gonna give you the score of each student, and they're gonna ask you which student performed better, stuff like that. So you're gonna be given the mean and the standard deviation. Have I answered your question?
Yeah, and with the z-score, will we also have to know how to do the standard error?
No.
Okay.
This is not a problem of standard error. We haven't reached there. Like right now, you're only talking about the use of z-score. Then the conventional z-score, where you're focusing on raw data, X.
Okay, yeah, you answered my question. Thank you.
Okay. Now, and this particular, like I said, is gonna worth 12 points. I wanted to take note of all of this. Now I want to go to question 5 now. Because I need a room. What I'm writing right now is being recorded. I'm actually gonna publish the link to the recording. Now I want to go into problem 5 now. Give me 1 second. Um, okay. So problem 5. Let me see. I think that one is okay. So uh, okay. So let me see. Problem 5. Give me 1 second. I think I run out of something. Let me just. I'm gonna fix that now. Should be working now. Okay, so problem 5. Now, problem 5, we test your knowledge on discrete type probability distribution. Okay, discrete type probability. Okay, distribution. You have it in the exam 1 practice as well. Now, so I need you to revise your knowledge of discrete type. Okay, understand how we calculate the mean. How do we get the mean? And how do we get the standard deviation? Okay, for a discrete type. You remember when we're dealing with discrete type that we actually, let me give you this, you're gonna see what I'm talking about now. Okay, so in a discrete type, okay, that you're actually gonna have, um, you know, you're gonna have uh stuff like this. They're gonna have something like this. But they're gonna say X, they're gonna say P of X, they're gonna say 0, 1, 2 or something, and they're gonna put some probability values here. You get what I mean? And they're gonna say, what is the mean of X? Okay, what is the standard deviation? Of course, the mean of X, you're gonna multiply and you add them up. Okay, so watch out. How do we do the mean of X? How do we do the the standard deviation of X? So check your notes on that. And that problem 5, we actually worth 8 points. 8 points. Problem 5, we worth 8 points. Okay? It's going to worth 8 points. So problem 5, we actually focus on discrete type, probability distribution. Okay, where you need to revisit how do you compute the mean, how do you compute the standard deviation. Now I'm going to go to problem 6 right now. And you know what? Problem 6 is where you're going to have R, and I'm going to explain to you right now. Okay, so problem 6. Problem 6. Now, the problem 6 will test your knowledge on binomial distribution, okay, and the sampling distribution. Oh my God, what we finished on Friday. Sampling distribution of a p-curve. And I'm going to explain this to you. On the binomial distribution, you actually need to know how to find mean. How do we find mean in binomial? Is NP. How do we find variance? Okay, is NP into 1 minus P. NP into 1 minus P into 1 minus P. Okay, and the standard deviation is just going to be the square root of the variance. Okay, there is not going to be, you are not going to make use of R for that. You're going to make you don't you are, there's not you are not going to make use of R for the binomial. But where are you going to make use of R? In the sampling distribution of a p-curve. Now, what you need to revise in the sampling distribution of a p-curve, you need to know what are the conditions to attain normality. Okay, when we're talking about proportion. So the condition, I think I'm going to do this, because I need more room. I'm going to emphasize on problem 6. Okay, so on the p-curve, if I want to apply the central limit theorem, okay, I have to verify that this is, if I want to test for normality, I need to test this for normality. Okay, I need to test this for normality. If the product of n and p is greater than or equal to 15, or the product of n and the product of n and 1 minus p greater than or equal to 15, then what I can say, I'm actually going to say p cap follow normal distribution. So what if they ask you to investigate whether p cap, which is the sample proportion, is normally distributed? Okay, you're going to investigate that. And after you investigate that, what are you going to do? They can ask you to find the mean and the standard error. So how do I find the mean? How do I find the standard error? Okay, you remember I said the mean cap, which is the mean of the sampling distribution, is always going to be equal to the population parameter P. Then what about the standard error? Okay, the standard error now is actually going to be square root P into 1 minus P divided by N. You see that? That's really the standard error. So if that is the standard error now, if I now want to write the distribution of a p cap, so if I want to write a distribution of a p cap, I'm actually going to write p cap, okay, follow normal distribution with the mean that I got, okay, and the standard error that I got. Okay, now watch out for question like this. Now see on problem 6. What if they ask you to find probability associated with the p cap? For instance, maybe they wanted to find what is the probability of a p cap maybe less than 0.7, I'm just assuming, or the probability of a p cap maybe greater than maybe 0.5, okay? What is the probability of a p cap lying in between? Now, if I want to answer the question that has to do with what is the probability of a p cap less than 0.7, for instance, I'm just assuming. So what you're going to do is you actually need to standardize. You remember, if I want to standardize, I want to find the probability, I want to find the probability of a p cap less than 0.7. That will be the probability of a z less than the formula p cap minus p over the standard error of the p cap. Okay, now this guy is going to be 0.7 here, Then this is going to be P that they gave. They're going to give you a population parameter P initially. And of course, you know that the standard error, don't forget, is the square root of P into 1 minus P divided by N. So this particular P here is going to be the same P here. Okay? Now, in a situation like this, let's say maybe you get your probability of Z. Maybe at the end of the day, you got, I'm just assuming, maybe you got 1.5. This is going to be P norm, 1.5, right? So we're going to make a suggestion about the arrow code for you. But you know what? For you to understand what we're doing right now, somebody said you can use, somebody said on chat, you can only use those equations if it is normal. Yes. And that is the reason why you need to verify first. Okay? Your verification is going to be if the product of NP is greater or equal to 15, and the product of N into 1 minus P also greater or equal to 15, then it is normal. Then if it is normal, don't forget I say that in class, normality facilitates standardization. And what I say standardization means the use of z-score. Okay, now what I want to do right now, I'm actually going to stop my share, and I want to give you the idea of the one that involve R, like in the exam practice. Some of you have been wondering whether in this exam, whether I'm actually going to, whether you're going to use your house software or that. You're not going to use your house software. You don't need a laptop for this exam. You only need your scientific calculator. Okay, you need your scientific calculator. Then you need a cheat sheet, 2 pages, just 2 pages of cheat sheet. One sheet like this. One sheet, double-sided. Okay, A4 paper, one sheet, double-sided. Okay, you can type, you can write, there's no problem. I'm okay with that. Now, I'm actually going to share a particular, give me 1 second, um, in the exam practice. Let me see. Give me 1 second. I want to check for the exam practice now, so that I'll be able to, let me go to Canvas. For those of you who may not know where the exam practice is on Canvas, let me first share the Canvas with you. Somebody said, Sabo said no calculator, so I've changed my mind. You are actually using calculator. So that is the reason why this is very important. The review that we're having today, the revision, notice can change. Because if you don't use calculator, it's going to take forever for you to figure out some problem. And that's why I'm changing my mind. So in the exam, I allow scientific calculator. Okay, so I'm going to show you, this is model. Okay, this is model. Okay, now I'm going to show you where the exam one practice is. I will advise you actually get yourself familiar with exam one practice question. Okay, if you get yourself familiar with exam one practice question and you review what we've done before, you're actually gonna get more than A in this exam. I actually wanted to get more than A. Okay, give me 1 second. I think I posted that a long time ago. I'm gonna take it gently. Okay, it's right here. Can you see that? This is exam one practice. This is exam one practice solution. Okay, I'm actually gonna open that now. And you know what? I'm gonna start with question that has to do with R. Okay, which is problem 6, part of problem 6. Okay, we have to do with R. So I think I'm opening that right now. Okay, I'm gonna open that. Okay, confirm if you can see this. Can everyone see this? I need
Yeah,
someone to confirm.
yeah,
Okay,
yeah.
thank you so much. Okay, thank you so much. Oh, thank you for confirming that. Now, I need you to look at this instruction here. Okay. Now, all what we allow, this is going to look like this. Look at that.
Hey, because
Okay, go ahead.
I think somebody had a question. They asked if problem one has 14 questions. Is every other problem just one question, or do they also have like multiple parts?
Oh, oh, thank you so much. Problem one, uh, the 14 question in problem one are multiple choice. Does that make sense? Multiple choice, just one question. Just choose the correct answer. That's all. You don't need to work it out for the multiple choice, problem one. Okay, so in the chat, somebody said one so problem one has 14 questions and every other problem only asks one question, or does problem 2 to 6 have multiple parts to them? No. In the okay, this is what happened. Problem one is multiple choice, like I said, 14 questions. Problem 2 to 6 has multiple parts to them. I'm going to say that again. Problem 2 to 6 has multiple parts, just like what you see in the exam one practice. I don't know if I've answered the person's question. Problem 2 to 6 have multiple parts to them. And somebody said, okay, thank you too. Somebody said, a graphing calculator allow? No, no. So I'm sharing with you the instruction. Take a look at this. It's going to look like this. Okay, you may use a calculator and a one sheet of paper. Take a look at that. Okay, with formula or other notes on both sides. You see that? So it's going to look like this. Okay, so what I want to do right now, I want to start with the problem here that has to do with R, so that you're going to have a sense of what we're talking about the suggestion of code I told you the other time. So because of that, I actually want to start from problem 6. I mean, from a problem here that involve R. Okay, I'm trying to look for the problem here that involve R. Okay, now take a look at this. Take a look at where we are here. Do you see do you see that as part of this question? What is this? Look at that. They give you a question. What did they say? P norm 0.5 is this. P norm 1.5 is this. P norm 2 is this. You can see that? They make a suggestion to you. And that was why we said the following output may be helpful. Now, let's say I want to solve this problem now. I need you to pay attention. Okay? If I want to solve this problem now. He said a line up for tickets to a local concert at an average mean waiting time of 25 minutes with a standard deviation of 5 minutes. You can see here, you've been given both the mean and the standard deviation. Now the question now say, what percentage of the people in line waited for between 22.5 and 32.5? Now, I want to solve this problem now. If I want to solve this problem right now, I'm actually going to interpret it as this mathematically. Can you see that? And you know what I need to do? I need to standardize. To standardize for this value, I'm actually going to standardize for that value. That's what you see me doing here. So the particular formula that I'm actually using right now, okay, is Z equal X minus mu over sigma. Look at that. Okay, that's what I'm actually using right now. So my X random variable is 22.5 and 32.5. And don't forget, you've already been given the mean of 25. You've been given the standard deviation of 5. And take a look at what I have right now. At the end of the day, okay, I actually have this guy. Okay, now when I have that guy, okay, I'm actually going to rewrite it as this guy, right? You remember the way I did that in class? Now, if I now want to apply a P norm now, okay, now if you take a look at, I'll give me 1 second. I'm actually going to clean up now. If you take a look at this guy, okay, you're actually going to see this guy who requires that I should use P norm of 1.5, right? And where is the P norm of 1.5? It's suggested for you is right here. That will be 0.9332. Look at that. Okay? Somebody says showing your work on each problem required to receive full credit. Yes, you have to show your work to receive full credit.
How much
Yes.
how much work do you have to show? Like if you can figure out that P norm is 0.5 and the other, or sorry, if you can figure out the R commands, like you can find the z-score of 0.5 and then 1.5, can you just skip like the middle part and just go to 0.9332 minus 0.3085 equals 0.6247?
Yeah, that is why this particular review is very, very important. We want it the same way it is done here. Look at the way it's done. Because if before me to go from P norm whatever to whatever, you see the way I put it. So we want it to be sequential like this. And that was why now, if you take a look at this guy now, okay, you're actually going to see, at least I need you to pay attention. You're going to see what I'm talking about now. Look at this one. That one will require P norm of negative 0.5. But if you look at the suggestion, there is no P norm of negative 0.5. But in statistical theory, please pay attention. The probability of a z less than negative a is the same as the probability of a z greater than a. I'm going to say that again. The probability of a z less than negative a is the same as the probability of a z greater than a. So which means what I'm trying to say, if you take a look at this guy, the probability of a z less than negative 0.5 is the same thing as probability of a z greater than 0.5. And you know what do we normally do greater than? It's going to be 1 minus p norm, okay, of a 0.5. Look at that. And of course, you can see here, do you see p norm of a 0.5? And that was why we actually do this. I will plug that in with a calculator. You're going to get your answer and multiply by 100. You have the percentage. Look at that. We want it to be detailed like this. And that's why we're giving you this as a guide. And that is the reason why I'm actually having this revision. I want it to go all the way like this. You should be fine doing this. Okay? So somebody say, why do we do 1 minus p norm of 1? Because the reason why we do that, I'm going to clean up again. Okay? If you take a look at what we have, oh, give me 1 second. If you look at what we have here, okay? This guy means p norm of 1.5 minus p norm of negative 0.5. But look at the suggestion. There is no p norm of negative 0.5. You only have p norm of 0.5, 1.5 at the line. And that's what I'm trying to tell you now is that take a look at this in statistics. The probability of z less than negative a is the same as probability of z greater than positive a. So what I'm trying to tell you now, this guy here is the same thing as 1 minus p norm of a positive 0.5. That's what I mean. So p norm of a negative is the same thing as 1 minus p norm of a positive when you have a less than. And that's why I did that. Okay, a chat came in again. Somebody said, in the p norm equation, what do 0.5 point? No, that's a suggestion. Okay, somebody said, what do they represent? Okay, I'm going to tell you what they represent now because they just giving you this suggestion. So what this guy is saying is that in case you want to find the probability of a z less than 0.5, okay, when you go to R and use P norm 0.5, this is the answer. That's what they are telling you. That's what that guy mean. And this guy mean, okay, if you want to find the probability of a z less than 1.5, okay, that will require you to use a P norm of 1.5 in R, it's going to give you 0.9332. We've already given you some answers. It is only left for you to go there and choose the one that is appropriate. And what p norm of 2 means is the probability of z less or equal to 2. And you can see here, you did not use that for question 3 here, okay? Because there's no area here where we have z to be 2, okay? I think I just answered the question that, that asked through the chat. Now, I want to go to question 4 under this problem. Okay, I want to go to question 4. Now, I need you to pay attention now. That's how that guy is done. Okay, you can see why you need calculator. Okay, now I need you to take a look at question 4 here. Please, I need you to pay attention. Okay, because this is also part of the whole problem. It said, if 2,000 ticket buyers were in line, how many of them would expect to wait for less than 15 minutes? How many would expect? If you want to, mathematically, you want to find the probability. Okay, so if they say, how many would you expect? Okay, you need to find the probability. And after finding the probability, you need to find the expectation. What do we mean by expectation? That will be the product of N and P. That's a binomial. The mean of a binomial. That's what they mean. Whenever, because they say, if 2,000 ticket buyers were in line, how many of them will wait for less than, so you said that they wait for less than 15 minutes or not. So what I'm going to do first of all, first find that probability. I standardize. You see that? Making use of the mean and the standard deviation they gave you the other time. What do I have? P norm of -2. Now, what did I say you're going to do? When you have a P norm of -2, when you have the probability of z less than -2, is the same thing as probability of z greater than 2, which is the same thing as 1 minus probability of z less or equal to 2, which is 1 minus P norm of 2. Now, do you now see the reason why they gave you suggestion in the first place? I'm gonna go up right now. Okay, do you see this suggestion? Give me 1 second. It's not going too fast. I'm gonna show you this. The other time they gave you p norm of 2 as part of the suggestion. Okay. Now, do you see that? Do you see p norm of 2 equal to that? I'm just gonna plug in that guy here. It's gonna be 1 minus 0.9972 now. So pay attention to the suggested code. Okay. Now somebody said, yes, now I understand. Okay, I'm so happy that you understand. And somebody said, I think, let me see. Somebody said, take a shot, give me, let me see. I want to look at it very well. If it is binomial, what is the success and failure in the scenario? Okay, if it is binomial, that's a very good question. So somebody say, if it is binomial, what is the success and failure I'm going to tell you now. The success is those who wait less than uh 15 minutes. They asked that was in this particular problem. Now take a look at this. They said, you see that? Those who wait less than 15 minutes, because it said that you wait less than 15 minutes or not. So the success in this situation now is the number of people who wait less than 15 minutes. Somebody said, are you going to post the Zoom video? Of course, I will definitely post my recording, this recording, just like the way I've always been doing. I've posted all other recordings. I'm actually going to post this one as well. Okay. Now you can see the way that actually play out. Okay. Now what I want to do right now, I actually want to go into one of the questions. I'm going to go to the multiple choice. And of course, like I said, I'm actually going to continue with this on Wednesday. But you know what? I'm actually um, going to show you some multiple choice right now. I'm going to go to other questions as well, okay, on, on Wednesday, okay? But let's take a look at the multiple choice. Like I said, question number 1 is going to be an extra credit point. Question number 1 in problem 1. There are going to be 14 questions in problem one. But question number one, okay, question number one is going to be an extra credit in problem one. So don't forget, there's going to be there are going to be 14 questions in problem one. There are going to be problem 2 to 6, we have multiple parts. Okay, now take a look at, I think I'm going to start with the one that some student has questions, they send me a message. Let me start with the last problem in multiple choice so that I'm actually going to flow. Okay, so let's start with so I'll be able to have a way to address, the kind of questions that I receive. Now, let's take a look at question 15. But like I said, in your real exam, you're only going to have 14 questions in the multiple choice. In this practice, you're having 15. Now, let X be a random variable with a mean mu and a standard deviation sigma. Let X1 up to Xn be a random sample of size n and denote the sample mean as S bar. Which of the following statement about the sampling distribution of X bar is correct? Let's take a look at option A. The option A said the mean for the sampling distribution of S bar depends on sample size. That is not true. You remember I told you in class that irrespective of the sample size, this guy, the mean of the sampling distribution is always going to be equal to population mean, irrespective of the sample size. They're going to be equal. Okay. Now, right now, the option A said it depends. No. So that's why this is false. Then option B said the standard deviation for the sampling distribution for S bar is sigma over n. That's not true. Can somebody tell me the correct formula for extra credit for the standard error for X bar? Can somebody tell me? Here they say sigma over n. What is it going to be for extra credit? Can somebody
This
say?
this square is the square root
Sigma by
of
square root n.
Okay, so which means sigma over, okay, for those of you who send me a message, I can see the chat. Send me a message for extra credit, and those who say it, send me a message for extra credit. It's supposed to be sigma over root n. So B is wrong. B is false. Please pay attention, okay? Pay attention. Now C, it said if X is a discrete random variable, then the sampling distribution of S never approximately normal, no matter how large sample is. This is also false. Okay? So this is not correct. Okay? Because if the distribution is not normal, okay, when sample size is large, it's going to be normal. Okay? Now, let's take a look at option D. None of the above is correct. Yes, option D is the right option because none of this is correct. Okay? Just wanted to take note of that. Okay, now I'm going to go to question 14 right now. I'm going to go to question 14 right now. Okay, now take a look at question 14. If the data is approximately normally distributed, then about dash of the data is expected to fall within one standard deviation. Here you're actually going to use empirical rule 68, 95, 99.75% empirical rule because they mention normal distribution. Okay, empirical rule apply to normal distribution. Oh my God, it applies to normal distribution. If you take a look at the question here, okay, by empirical rule, 68% will fall within one standard deviation of the mean. 95% will fall within two standard deviation of the mean. 99.75% will fall within three standard deviation of the mean. Okay, so make sure you revisit the empirical rule. Now, I'm going to go to question 13 right now. Now, looking at question 13 right now, let a random variable X represent the amount of money, that make doing lawn care in a randomly selected week in the summer, assuming that X is normal, with me $240 and the standard deviation $60. The probability is approximately 0.6 that in a randomly selected week that we make less than. Okay, now, if you take a look at this, they're asking you X. You remember what we did the other time. Okay, you remember this formula? X is going to be equal to mu plus sigma or Z sigma. Okay, so this is like you want to get your X. Okay, now right now the mean is 240. Okay, this is going to be 240. The standard deviation is going to be 60. Okay, now you want to figure out what is Z. Now, if you want to get Z now, okay, you can use empirical rule. What did they talk about here? You know, that guy means 60%, right? Do you know that for 60%, when you talk about 68% for empirical rule, that will fall within one standard deviation, right? Okay, for that will be that for 68%. So for 68%, we're gonna say Z fall within -1 and 1, right? But actually gonna say so 60%, 60 not far from 68%. That would be like a 0 point something. So you right here, there's gonna be like a 0 point something. Okay. Sorry, I'm not gonna say 0.9, but it's gonna be less than 1. Okay. Let's assume if this guy is 1, if Z is 1 for for uh for 68%, if this guy is 1, it's gonna be 240 plus 60. That will be 300, right? But it's not going to get to 1 because it's 60%. So definitely that is why this is going to be reasonable, because 240 is already greater than 144. 240, the mean, is already greater than 216. And there is no way that is going to get to 360. It's no way, because you have 240 plus 60, and that Z is just a fraction that will bring it down. It's not going to get to 300 at all. And that was why the reasonable value here will be 255. Okay, now that's how that one is done. I think I have let me see. I think I have 4 more minutes. Okay. Uh, everyone is still hearing me clearly, right? So everyone still hearing me clearly? Okay, thank you so much. Thank you for confirming that. Now I want to go to question 13 now. Okay, let the random variable s. Oh, sorry, I think I've already done 13. I'm actually gonna go to 12. Okay, now, oh my God, this is one of the questions that you're also going to see in the short answer question I talked about discrete type the other time. An insurance company has estimated the following cost probability for next year on a particular model of car. Whenever you have something like this, of course, that's a discrete type, right? That's a discrete type probability distribution. Now they want you to find the expected cost. Expected cost, you're going to multiply this by this, you're going to multiply that by that, that by that, by that, by that, you're going to add them up. Then you add them up, and that will give you this guy. So expected value means this. Expected value of x. You remember? Summation x, probability of x. Okay? This is like x. This is the probability of x. Take a look at that. Okay? I needed to pay attention to that. A shot came in. Oh, okay. The person just said yes. Okay, you know what? This is where I'm actually going to stop today. Like I said, I'm going to return to in-person teaching on Wednesday. My emergency is already clearing out. Okay, my emergency is clearing out. Now I want to appreciate every one of you who actually attended my lecture today, my review today, despite very short notice. Okay, so like I said, I'm fine. I'm fine. I'm actually going to return to in person on Wednesday. Okay. Now somebody said we have homework assignment this week or no? I think I will advise that you always check syllabus. If you go to the syllabus, it's going to say there is no homework on the week of midterm. So you don't have homework this week at all. We want you to focus more on your exam, because we want you to do well on this exam. Like I said before I go, you need to go to, what is it called? review the exam one practice question. It's already published. Then our assignment solution will be uploaded uh, at the end of today, because I think tomorrow, because we're still going to have some students, because today is our deadline for submission. So, and that's why you're going to see all the solution will be uploaded on Canvas. I've already uploaded recordings for past lectures, and I'm also going to put this on Canvas too, because this one is going to be. Now, somebody said, are you going to post the Zoom video? Yes, I'm actually going to do that. I'm actually going to post this on Canvas the way I've been posting my uh, lecture recording. Okay. Like I said, I'm going to see you in class on Wednesday. I'm going to return to in person. Make sure you all stay safe and have a lovely day. Bye for now, everyone. See you on Wednesday. Yeah, yeah. Right. Thank you. Thank you too. Thank you. Yeah. I miss you guys. I'm going to see you on Wednesday.